Hey folks, we're into chapter 7-1, over a century of capital market history in one lesson. Folks, take a look at the graph on the left called nominal. This charts the performance of treasury bills, bonds, and common stocks over a 110-year period from 1900 to 2010. This graph reflects the data captured and published by Dimson, Marsh, and Stoughton in their work Triumph of the Optimists. What does this graph tell you? This graph tells you if you invested $1 in treasury bills, that is short-term government bonds, in the year 1900, by the year 2010, you'd have $74. If you had instead invested in all government bonds, long and short-term maturities, maybe from just less than a year up to 30 years, you would have invested $1 and had $245 in the year 2010. But if you had invested in the U.S. stock market, in common stocks, $1 in 1900, you'd have $21,978 in the year 2010. Think about that. That's an astonishing performance for common stocks. No matter what you invested in the year 1900, you would have 21,978 times your investment. If you invested anything sizable in the year 1900 and were able to let it sit in common stocks for 110 years, you would be filthy rich. On the right, we have the same graph, except it has been adjusted for inflation. Sometimes we want to ask ourselves, what's the real rate of return? That is the nominal rate of return adjusted for inflation. Inflation is rising prices. As prices rise, my purchasing power decreases. So even though my total money increases due to my investment in treasury bills, bonds, or common stocks, the purchasing power is at the same time being eroded by inflation. So let's see what we get in this real graph. If we invested $1 in T-bills, over the 110-year period, we would only have seen a 280% growth in our investment. $1 turns into $2.8 in 2010, meaning treasury bills just barely outpaced inflation over the 110-year period. Bonds didn't do much better. Right? If we invested in all government bonds, $1 in the year 1900 yields us $9.30 in the year 2010. But if we had invested in common stocks, even after adjusting for inflation, you invest $1 in 1900, you have $834 110 years later. That's still a whopping rate of return. Now you're probably wondering, well, should I be looking at nominal or real? For the most part, when doing finance, we look at nominal rates of return. Why? Because we can't do anything about inflation. That's not within the control of a financier. Same study, Dimson, Marsh, and Stoughton from the Triumph of the Optimists, but now we look at the information on an average annual rate of return basis in a chart. What did treasury bills produce on average each year? 3.9% on a nominal basis. All government bonds, 5.4%, common stocks, 11.3%. You should memorize these numbers. Treasury bills are called the risk-free rate. Why? Because treasury bills are loans from investors to the U.S. government, which is a safe investment. Why is the U.S. government a safe investment? Well, the U.S. economy is by far the largest and most stable in the world. The U.S. government has been the most stable democratic government in the world. If you're going to park your money somewhere, you can park in the United States of America and assume you'll actually get back what you've been promised. Especially treasury bills. Treasury bills, as opposed to bonds, are considered the risk-free rate because treasury bills have a maturity less than a year. It's probably true that the U.S. government isn't going to go bankrupt. The United States is not going to fall apart and default on its bonds in the next year. So treasury bills are considered the risk-free rate. Government bonds, since you're investing in some 30-year bonds, you never know what happens to the world in the next 30 years. Something terrible could happen. So there's more risk involved there. So you'd expect more return. You get return for risk. Therefore, the average annual rate of return on government bonds over the 110-year period, 5.4%. In common stocks, a lot more risk, so a lot more return, 11.3% on average. Now understand, 11.3% average annual return for common stocks is an arithmetic average. It is just a simple mean. What do I mean by that? If I have the numbers 1, 2, and 3 and I want to know the average, a simple mean, arithmetic mean would be 2. That's what we got there in 11.3%. If you wanted to take a geometric mean, that is a compound annual rate of return for common stocks, kind of like we would have looked in chapter 4, even chapter 3 or chapter 2, when we're looking at discount rates, right? In that case, you're talking about a 9.3% compound annual rate of return for common stocks. But for purposes of chapter 7, and the math will bear this out, though we won't look at it, we should be looking at rates of return of 11.3% for common stocks. Look on the right, you see average risk premium, extra return versus treasury bills. This is the extra return you get for taking on more risk above the risk-free rate. Notice the risk premium for treasury bills is 0 because treasury bills are the risk-free rate. Government bonds, 1.4%. You get that additional amount of return for investing in government bonds over the risk-free rate. Common stocks, average risk premium over 110 years, 7.3%. That's what you're getting paid for the extra risk you're taking above and beyond investing in the risk-free investment, which is treasury bills. The question becomes, should we be referring to nominal rates, real rates, or risk premiums? Well, some people believe in talking about risk premiums. They think that's a more stable number to deal with. Some people who are hyper-focused on issues of inflation may talk often about the real rate, but for most of us in the investing world and the financing world, we're thinking about nominal rates of return. That's where our mindset is. So to repeat, common stocks produced a nominal average annual rate of return of 11.3% from 1900 to 2010, which equates to a 9.3% compound annual rate of return over the same period. If the cost of capital is estimated from historical returns or risk premiums, use arithmetic averages, not compound annual rates of return in Chapter 7. Let's talk about the idea of risk premium. Some people are big believers in focusing in on risk premiums rather than nominal rates. For those people, they would say, in theory, rather than saying, since the stock market has produced an average annual rate of return of 11.3% historically, it should produce an annual rate of return of 11.3% going forward. It's better to say, since the stock market produced an average risk premium of 7.3% historically, it should produce a risk premium of 7.3% going forward. For these folks who are big believers in risk premiums, they say that's where our focus should be. So on 10/17/22, the risk-free rate, the rate of return being paid for treasury bills, was 4.28%. If I wanted to focus on using risk premiums to tell me what my expected rate of return on the stock market is going forward, what I would do is I would say that expected return on the market should be the risk-free rate today plus the average risk premium over the 110-year period. In other words, 4.28% plus 7.3%, which equals 11.58%. So we notice that 11.58% is slightly higher than the 11.3% nominal average rate of return historically. Which one should you look at? Should you be calculating the market portfolio return based on today's risk-free rate plus the market risk premium? Or should you just be looking at historical nominal rate of return? The answer is we will, as a class, focus primarily on just the historical nominal rate of return, which is 11.3%. But you should be aware of this because some people are big believers in the stability of risk premiums.